All right. So today we're doing graphs of F prime, and F double prime. So really, I feel like this topic's kind of repetitive, but we'll just kind of see what you remember. So this says F prime of X. Okay, but we're going to use the graph of F prime to make conclusions about regular F. So this is not the graph that we're answering questions about, but we're going to use it to answer questions about a graph that we don't have. Okay, so it says we have F prime, horizontal lines at -3. We have one at 2, and then we have one at 5. It says you have a vertical tangent at 3. So that means that right here, it just happens to go vertical. So look at that first one. Hello. Yeah. That's okay. She just got here. Yeah, I don't know. We're just doing these for AP review. I don't want it to be stressful, you know? Yeah. Where I approved it.
You have me background setting?
Yeah, maybe it got put in there backwards, but I do have both your girls. Okay, thanks. Okay, bye. Yeah, we're doing these. Okay, so if I want a minimum, remember that for F to have a minimum, F prime of X has to change which way?
Ooh, pick me one, pick
Hey,
me one.
Ashton, we're in the middle.
I raised my hand.
Go away. Shh. Sorry, this is my child. Hey, seriously, stop.
I have an answer.
Stop. Okay, which way does it have to change sign? Okay, bye. Do you know? Thank you. Negative to positive. Okay, so when I'm looking at my graph, my critical numbers are going to be all of these spots along the x-axis. But in order for it to be a minimum, it has to go minus to plus. So where does that happen? -1. So you would put x equals -1 because F prime of X changes minus to plus. Now, while we're at it, -1 is a minimum. What type is -5? Max. And then what would +5 be? No change. So this would be a horizontal tangent, but it's not a min or a max. So essentially what the graph does is that it increases because we're above, it flattens out, but then it keeps going uphill. Okay, next one, we want a relative max. Oops, we already answered that. So X equals -5 because F prime of X changes from plus to minus.
Are we able to use these shorthands on that?
Yes,
Okay.
yes. I wouldn't get like too crazy, but like plus to minus or like BC for because. If it's even min and max, instead of writing it out, those should all be fine. Okay, next one says I want the second derivative, so F double prime to be less than 0. So if this is a graph of F prime of X, what feature would F double prime be? Very good. So I'm going to put here F double prime of X is the slope on this graph. Okay. And then specifically, we're wanting F double prime to be less than 0. Is that positive or negative? So where are our negative slopes? Okay, -7 to -3, so list that. Okay, now 4, 2 to 5, you have to be a little bit careful here, and here's why. What happens that they specifically told you about at this point? It's undefined, right? It's vertical. So is the slope at that point technically still negative? No, so you should break it down and say from 2 to 3, and then from 3 to 5. Okay, but the reason that you have to break it up is because they're specifically wanting the second derivative to be negative. then undefined wouldn't count because it just goes vertical at that one spot. Okay, and so that's where a lot of times in class, we kind of like skip over reading the paragraph. But usually if they're telling you specific stuff like this, it's because it does matter at some point. Okay, go ahead and turn the page. All right, next one. Go ahead and do part A. So it says you have a figure above that shows the graph of f prime. The fact that it's twice differentiable just means it doesn't have any like cusps or corners, but you can also see that from the graph. Okay, then it says you have your horizontals at -1, +1, and 3. And then it tells you that the areas of the regions bounded by the x-axis on -2, 1, and 1, 4 are 9 and 12. So that means this area is 9, that area is 12. Okay. So looking at your graph, where do we have a max? Dyson, go ahead and grab your packet. -2. So we would put x equals -2 because f prime of x changes from plus to minus. Okay, then second part of this says find the absolute maximum and minimum. So remember, for a relative, all that you need is it to pass through the x-axis the correct way. Okay, but remember, you can have multiple relative maxes, you can have multiple relative mins, but once you get to absolute, there should only be one. Do we remember what kind of chart we have to do for these? Very good. Okay, candidates chart. So remember, for a candidates chart, you're going to list the endpoints. So in this case, it would be from -2 to 4. And then you would also list any critical numbers between those. Remember, your critical numbers are where it hits the x-axis. So -2 is going to go on there. And then we'll say 1 will go on there. And then 4 is already an endpoint, but it is also a critical number. Okay, at -2. Actually, I added this question in, but they need to give you the starting value. So let's add something here. Let's say that it is given that f of -2 is 10. Because they have to give you like a starting point. So at -2, they told me that it's 10. How much area is accumulated from -2 to 1? So from here to here, how much area does it change? 9. Should I add the 9 or minus the 9 if the area is below?
Minus.
So if it was 10 and I take away 9, my value is now a 1. Okay, then for my second little pocket, from 1 going on to 4, I'm going to lose another 12 of area. So if I minus 12 more, that makes that -11. So then from there, we could say, what is our absolute max? So make sure when you list it, you want to list the y value. So it is 10 and it occurs at x equals -2. Okay, so the max is exactly how high it goes. Okay, and remember, we're not talking about this graph. We're talking about a graph that we don't have a picture of. Okay, then for the min, what would you say? -11. So your absolute min is -11. And it occurs at x equals. Okay, and I would always answer the question with that little sentence because sometimes they want the max, sometimes they want to know when the max happens. That way you're just always answering the question. Okay, but that's really only for absolutes. Okay, next question says, on what interval from -3 to 4 is the graph of f concave down and decreasing? So if I want it to be concave down and decreasing, they're giving me specific signs for f prime and f double prime. For concave down, what do they want? F, f prime, or f double prime? F double prime, and what does it need to be? It needs to be negative. what feature is f double prime on the graph of f prime that we're looking at? This slope. Okay, so I'm gonna put right below that f double prime is really the slope of f prime, which means I just need it to be going downhill. Okay, second thing I need is for f to be decreasing. Well, for decreasing, is that f prime, or f double prime? Decreasing is f prime, and this is the graph of f prime already, right? So if I want this graph to be negative, where am I looking for it to be? The y values to be below the x-axis. So I'm going to put here y values below. So look on your graph, where do we have that combo? Because it has to be both since it says and.
Good morning, Eagles.
So below and negative, where are we picking?
Eagle Eye, please tune in now. Have a golden day.
-2 to -1, and then one more spot. 1 to 3. Very good. Okay. And then something like this is sufficient for a justification. You don't have to write like a big long paragraph after. Okay, just make sure that you're talking about the graph that they gave you. So if it's a graph of f prime, your explanation needs to have something to do with f prime. Okay, last part asks for points of inflection. Points of inflection are when which derivative changes sign, first or second? We need the second derivative to change sign. And then what feature is that on this graph? The slope. Okay, so I'm gonna put here, I need the second derivative to change sign, but I know on this picture, that's gonna be the slope. And remember, usually I'd mark those just with X's. So think like the tops and the bottoms of the roller coaster. So I'm downhill till when? -1, then I go uphill till 1, then downhill till 3. So it'd be x equals -1, 1, and 3. And then I'll just put because that. Questions on that? All right, go ahead and turn the page. All right, so next one is pretty similar. The only difference is it's a velocity graph. So let's go ahead and maybe we won't do the whole thing, but we'll do a little bit of it. So we have a velocity graph. And we know that velocity is the first derivative of position. So it does give you the areas. Go ahead and mark those. It says the area of the regions bounded by the graph on 0 to 3, 3 to 5, and 5 to 6 are 8, 3, and 2. So 8, 3, and 2. Okay, then it also says right here that at time 0, the particle is at -2. So for part A, it says find both the time and the position when the particle is farthest to the left. Do they want a max or a min? Which one? A min, right? Because on the number line, if you're going to the left, that's where the smallest numbers are, right? So they're asking you for an absolute. Then we know that we need to make a candidates chart. Okay, remember your endpoints need to go in first. So we know we're only looking 0 to 6. And then any critical numbers. So in this case, I see that I have critical numbers at both 3 and 5. Remember, they have to give you the position. If you're looking at velocity, that can't tell you where your position starts at. So remember, our last sentence did that at time 0. What is the position? -2. And then think about from 0 to 3 seconds, what's your displacement or your area on your graph? -8 because it's 8 below. So if I start at -2 and I go backwards 8, where am I at now? -10. So I'll put -8 because of area. Okay, then from 3 to 5, how much area do I get? +3, so that would put me at -7. And then my last second, I lose 2, which would put me back at -9. So looking at those spots, it says find both the time and position when it's farthest to the left. What is my minimum? -10, -10, and it occurs at t = 3. Okay, and in this case, you can see they ask you for both, not only what the minimum position is, but when it happens as well. So that's why if you just always get in the habit of writing that sentence, you're always answering both questions. Okay. Next question is kind of related to this. It says, how many times from 0 to 6 is the particle at -8? Okay, so I want you to think about this. Is really intermediate value theorem, which we haven't touched in a while. But if -8 has to be hit, that means that when you go from here to here, you're passing through it. So from -2 to -10, would I have to hit -8? Okay, that's one. From -10 to -7, would I have to hit it again? Yes, and then from -7 to -9. So I have to hit it at least 3 times. Could you have gone through it more than that? Yes, but IVT only promises you have to hit any numbers between these. So we would say at least 3 times. And then I'm gonna put IVT guarantees this. Since -8 is between the positions at 0 and 3. Then again at 3 and 5. And again at 5 and 6. Okay. Now, if you can think of a shorter way to say that, that's fine, but that's fine. Okay. You do want to make sure though, if you're using a theorem, IVT is acceptable if you don't want to write out intermediate value there. Okay. Next question asks us about speed. Do you remember what has to be the same sign for speed? Is it position, velocity, or acceleration? It's 2 out of the 3. Acceleration and velocity, very good. So in order for speed to be increasing or decreasing, we need to check V of t and A of t. Now, this is a graph of velocity. So what feature is velocity? Y value. And what feature is acceleration? Slope. So I want to see, is it above with a positive slope? That would be speeding up, but above with a negative slope, that would be slowing down. So it says from 2 to 3, look on your graph on that little interval. From 2 to 3, where is my graph? Above or below? Below, that means that my velocity is negative. But my acceleration, which is the slope, is what? Positive. So if my velocity is negative, but my acceleration is positive, my conclusion is that speed is slowing down, or I'm going to put speed is decreasing. Okay. So then I'm going to put because velocity is less than 0 and acceleration is greater than 0. Okay, then I would make sure on this acceleration, I would write underneath it the slope of V of t. That way you're connecting it back to the information that you were given. Slope on V of t. Okay, that way it's very clear that you know what you were talking about at that point. Okay, next one asks us about acceleration. What feature is acceleration on the velocity graph? So if acceleration is negative, that means all I care about is the negative slope. Doesn't matter if it's over or under. Where does that happen? 2 sections. 0 to 1 and 4 to 6. Okay. Very good. Okay, maybe we'll just we'll skip the next page. You kind of need a calculator for, and I see you don't already all have calculators. So let's go to this page right here. Okay, and let's do the bottom one. Because we did this top one, I think, yesterday. So it says f is continuous such that f prime of 0 does not exist. Okay, if f prime does not exist, that means that it's not differentiable. Okay, differentiable means you can take the derivative. So if f prime doesn't exist, that means I can't take the derivative. What types of features could there be at 0 that would guarantee that I'm not differentiable? Cusp for a corner. Also, if it goes vertical, that also counts. So looking at your graphs, okay, which of these are not differentiable, meaning they have a cusp, a corner, or a vertical tangent at 0? A, B, C is out, because I can see, I could draw the tangent line there. Now at D, if you have a break in the graph, that actually also does count. Okay, next one says that f prime of 2 needs to equal 0. Well, if these are graphs of f, what would f prime of 2 be? What feature? Slope. So I need it to be flat at 2. So I have a flat spot at 2 here, 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 and here. So that doesn't really help us. Okay, and then I want f double prime to be less than 0. What feature would that tell us? Concavity. And if I want it less than 0, do I want it up like a cup or down like a frown? So it has to be concave down the whole way. Which graphs are still in it? Looks like just D and E, right? Okay, so this one has a concave up. This one has a concave up. So those are both out. Okay, and then out of these two that are left, there's got to be another way to eliminate it. F prime of 2 is 0. Oh, okay. Oh, it says it has to be continuous. I didn't even read that. So if it also has to be continuous, now which of these is out? B, so it's got to be. All right, I think we just have time maybe for one more. So let's try the next one. Okay, so it gives you some velocities. Okay, and then it says which of the following could be the position graph. So go ahead and take a look at your velocities. What would a velocity of 0 look like if these are position graphs? Horizontal tangent, very good. So which of these graphs doesn't go horizontal at 3? So this is 1, 2, 3. Am I flat on A? Not gonna work. Okay, 1, 2, 3. I'm not flat on B. Now notice both of them hit the x-axis at 0, but if it's velocity 0 and this is a position graph, velocity is what the slope should look like. Okay, then I have 1, 2, 3. I have a flat here. 1, 2, 3. I have a flat here. And then 1, 2, 3. We have a flat here. Okay, next thing I want to focus on is that this one actually has 2 flats. Where's the other flat on answer D? At 2, and if, oh wait, 1, 2, 3, I counted wrong. That one's actually out. Okay, look at E. Where's my other flat? At 1, and look at your graph. Is it supposed to be flat at 1? What's your velocity supposed to be? Then it should still be uphill at 1. It should have a positive slope of 2. So that would eliminate that and give you, okay, that you can see here at 1, you are uphill just like you're supposed to be. At 2, I'm still uphill. Then I flatten out at 3, and then at 4, I see my slope switches to downhill. So that's got to be the match. Make sense? Kind of remember it? Okay. It's 11:01, so we'll go ahead and pause there, but good job. Pull out your sheets for me to sign them.